All right, so we're going to start today with a brief preview of calculus. And the first thing I would like for you to do is I would like for you to think about what is calculus. Now, you may have had a calculus class before, and you may not have. But when you hear the word calculus, what do you think about? So jot down a couple of ideas. And then I'm going to give you a loose definition of what I would have to say calculus is. Okay? So just jot yourself down a couple of ideas first to get our minds thinking. Anyone who would share with me what you wrote? What would you say? There's really not a right or a wrong. What do you have?
I said derivatives, integrals, and their applications.
That's a good description. Mm-hmm. Did you have one?
Calculation, bodies in motion.
That's good too, this idea of something being in motion. Mm-hmm. Anyone else? Okay. One of the ways that I have seen it defined, again, loosely before, is that calculus is the mathematics of change, this idea of motion. But it doesn't actually have to be physical motion because there's other things that change too. So the premise that I'm going to work upon is that this is the mathematics of change. Now, there are a couple of different ideas that are very crucial to calculus at the beginning, and those ideas are secant lines and tangent lines. Now, the first place that you've heard the phrase secant line or tangent line was probably in not a calculus course. Where was it? It was in geometry, and you heard it in reference to circles, right? But it means the same thing, so that's really good. That doesn't always happen in math, does it? No, it doesn't. So that's a good thing in our case for this. So when we're looking at, make sure that this font size is right. That's okay. When we're looking at a secant line is actually a line that will go through something and touch it twice. That's what a secant line is. And we can draw that secant line just as well right over here. It has nothing specific to a circle. That's just the first place you've seen it before. Now, a tangent line is something different. It does not, when you're doing a circle especially, ever cut through the circle, right? It has this sort of bouncing off effect. So you can imagine the beach ball with, a plank of wood lying against it. It doesn't cut through the beach ball. It just touches the beach ball on the side. So when we're taking a look at drawing something like that, we might have a picture that looks something like this. And I had a student once describe this as though it looks like it's kissing the curve. Right? It's just touching it. It doesn't actually cut through the curve. And we can do that again with our curve just as well as with the circle. Now, there are more accurate ways of drawing tangent lines than I probably just did, and maybe even than you did, and we'll get more into that accuracy level later. But the idea remains the same, is that we're touching the curve and not cutting through it. Did forget to do something with me today. Bring something, that's okay. One of the things that we do with calculus, or can do with calculus, is to estimate slopes of things. Okay, so if you've had any experience with calculus before, this is a familiar idea to you. And one of the things that we can do is we can estimate the slope of a curve. Any curve, doesn't have to be a line. We can estimate the slope of that curve at a specific point on the curve. So this is the image that I have back over here. The image is actually being able to draw this line and finding the slope of that line. Okay? But like we said, how do you draw that line accurately? There's some sort of an error a measure of error involved if we're actually doing it with a picture point of view. Well, one way to do this is to do this numerically. So if you have your calculators, grab them and get them out. And I meant to have with me the calculator screen to project, and I didn't do that, so I'll have it with me next time to make sure that everybody's on the same page with me on that. But what I want us to take a look at is how we go about numerically estimating the slope. So there's a couple of things that we would want to be aware of. The first thing that we would want to be aware of is what is the y value at whatever this value is right here. So this says at a equals 1, and they're telling you up here that the a is some x value. Okay, so this 1 right here is an x value here. So if I put this into my function for x, what would I get as the y or output value? 3. So this is the ordered pair 1, 3. So the point 1 through is a point on this curve. Everybody with me so far? Okay, that's algebra, right? That's all we did was algebra. What we would like to do is we'd like to estimate the slope. But what do you need in order to find a slope of something? We need 2 points, and this is only 1, right? So I need a second point. Well, the way that we're going to get that second point is we want a point that's really, really close to this point on the curve. Okay? So what we're going to do is we're going to pick a point slightly larger. I'm going to pick the point 1.1. And then I'm going to pick a point even slightly closer to it than 1.1. I'm going to pick 1.01. And then I'm going to pick a point even closer, and what do you suppose it's going to be? 0, 0, 1. We're going to add another 0 in there, yeah. And what this is going to do is it's going to get those points closer and closer together, so we're going to get closer and closer to that image of that tangent line by doing that. Right? Now, you've got your calculator with you, so I want you guys to grab that out. I'd like for you to put in this x value, we'll do it one at a time, into this function x cubed plus 2. We need to know what the corresponding y value is. Because like you guys said, I need 2 points in order to calculate slope. And right now I've only got 1.13, and I've got some x coordinates. So what do you get when you put in 1.1 into this function? Is that it? Okay. So this is our y value here. What happens if we put in 1.01?
That's 3.0303.
Excellent. And as you're doing these tables, as long as you've got about 4 decimals, this one doesn't. This one actually terminated, didn't it, Nikki? So that's fine. But if it keeps going beyond that, that's okay. As long as we're about 4 decimals into this, we're okay. All right. 4 to 6 is what you'll see the book doing most of the time. What about 1.001? Three point something. Did you get one?
Oh, yeah, 3.003. Sorry.
Did it go 003 again?
It's
Just for
fine,
fun?
I just have it.
Okay.
Or it's only gone 3 decimal windows.
I'm going to put that. That's what I have written down, is that it duplicates this image. All right, so we're going to calculate the slope on this, but since we're already geared up to putting values in, I'm going to go over here to this other table. These values for x were slightly larger than the number 1, right? They're all a little bit bigger. We're going to do the same thing over here with values that are slightly smaller. And we're going to start with the value 0.9. That's pretty close, isn't it? And I'm going to get something a little bit closer. What do you think I might be putting in next? 0.99, that's right. And if you weren't sure now, you should be at this point. What's the third one going to be? 0.999. 3 nines. Now, there's nothing real specific about me picking these points. They just seem nice. All right? And they need to be near value of 1. And they need to be getting closer to the value of 1 as we're getting further down the table for this to make sense. Does that make sense to everybody? Okay, let's put these 3 in one at a time and find out the corresponding y value for each of these. We know it's going to be close to 3, or at least we expect it's going to be close to 3 because all the values have been so far, right? So that's what we're sort of expecting. What happens when we put in 0.9? Does anyone have it?
I mean, I'll do you.
Okay, remind me your name.
It's Zach.
Zach. Okay, Zach, what do you have?
2.729.
Okay. What's your next one?
2.9703. And then 2.997.
Did it end at 2.997?
It only went to 3 on mine.
On yours?
It's 00299.
Okay, it's got some zeros next. This is fine then. We'll put a 0 there just so that we've got 4 of them. But yeah, that'll fine. It's fine.
I just did it in the table.
That's good. Yeah, that's how I would have done it too. Your table's a great resource. If you're not sure how to use the table in the TI-84s, touch base with me after class and I'll make sure I can show you how. Okay. All right, we're going to calculate slope. How do you calculate slope? Do you remember it? Does anybody remember the formula? We call it M for slope. Oh, you guys are going to have to get over being shy. All right, it's y2 minus y. I know you know it. y2 minus y1 over x2 minus x1. And there's some other phrases you've probably heard before that correspond to this. What are those phrases? Rise over run, delta y over delta x, yeah. And it really doesn't even matter that I put the y2 before the y1. I could switch those as long as I switch them on top and bottom. So I could have written y1 minus y2 and x1 minus x2. All right, so this is the form we're going to use. Okay, so I want you to go ahead and take a moment because this is just algebra. I'll write the first one in, but then you're going to do the rest of them for me. So we're going to take the first ordered pair right here, everything's going to compare back to the number 1, 3. That's our stationary point. Okay, so when I calculate the slope, the first one is going to be 3.331 minus 3 over 1.1 minus 1. So in all of your calculations, this 3 and this 1 are going to stay put, right? All that's going to change is this pair right here, the 3.331 and the 1.1. And they'll change corresponding to where you are on this table. Okay, so let me see. Show of hands, who has a calculator? Okay, who has a phone that has a calculator in it? Everybody else mostly. Go ahead and get your phones out for today only. All right, most of you have a scientific version of that in there. Just stay on task for me and don't go somewhere else on your phone. I'd like for you to calculate these slopes. We're going to calculate 6 of them. Okay? In fact, here, let's do this. How about, we'll split right here, down in the room. So this half over here, I want you to calculate the first table, the one that has the 1.1s and so forth. And then everybody over here, let's calculate the second table. Okay? So that we can go through them a little more quickly. You've already got the first one.
This regular calculator won't do it well.
No, but if you turn, most of the iPhones anyway, when you turn them, they can go nice.
Oh, let me
Turn
try.
them to a landscape kind of view. Okay, so take just a couple minutes to fill in your half of this. And after you fill in your half, we'll all fill the rest of it in together. You guys are doing this half over here. Now let's start filling this in together. What did you guys get for the first blank? I know I'm looking at this half of the room over here. What did you get for that first blank? Did you get one, Hannah? 3.31. 3.31. Does everybody over here, does that look right? Excellent. Remind me your name. Jamie, that's right. Jamie, what did you get for the second box? 3.03. Okay. So it's still close to the same value, right? But it's not quite the same. Remind me your name.
Grace.
Grace, what did you get for the third one?
3.003.
Ooh. Still close, right? What does it look like this number is getting really close to? 3. And it's very much a coincidence that it's the same as the 3 that's the y value. That's just coincidence, promise, okay? Promise. It won't be on the next example. But it looks like it's getting close to 3. So let's see what happens on the other half of the graph. So what happened? What did we get for 0.9?
2.71.
2.71. Well, that doesn't look very close to 3. Not as close as the other ones, right? Not yet. All right, what about the next one?
2.97.
Ooh, 2.97. That's closer, isn't it? How about that last box? You get that one? Did you get that one,
It
Zach?
rounded up to 3. I don't have an exact one.
Okay, it won't be exactly 3. Let me see what mine has.
I knew it was going to be lower.
Yeah. Mine had 2.997. Zach, you might want to change your calculator
I
to
think
give
it's
you a
right.
few more decimals. Yeah.
Decimal.
Try to let it go to 4 at least. Yeah. Okay, so once we at least get to the 2.997, are we pretty well convinced? It looks like it's also getting close to 3. So we're going to be on the safe side and say that we are going to estimate that the slope is 3, because this didn't really prove that it did, right? We're just sort of noticing this pattern and saying, man, it really looks like it's getting close to 3. So we are estimating. Now, it actually is 3, but that aside, we don't know that for a fact right now. That's our best guess based on this information. Does that make sense? So we're estimating that if we drew this line as a tangent line, that its slope would be 3. Now, I'm going to fill in with you the x values here on this table, and all I want you to do between now and Wednesday is to fill in the y value and calculate the slope, and you know how to do it because we've already done that, right? For the last example. That's all you have to do. You don't have to do the homework in this section or any of that, just to fill in the rest of this table. So on this one, notice that my a value, my x value, is pi over 4. So if I were to enter pi over 4 into the tangent function, what is the tangent of pi over 4? Now you may remember from a unit circle, or you may be able to use your calculator as long as you're not in degree mode, and you will never be in degree mode in this class. It's always radians, okay? What is the tangent of pi over 4? Do you remember? It is. It's 1. That's nice, isn't it? What is pi over 4 approximately? Give me a decimal. Grab your calculator. Okay, let's do a decimal with, where did I have it over here? Let's do a decimal with 3 decimal places. It is 0.7 something. 7 what? Can you put pi over 4 in there and what do we get? 785? Okay, so let's just go with 785 as approximation. This one isn't as clean as the last one. The last one was 1. So I could say 1.1, 1.01. I mean, it was cleaner, right? I need to pick values slightly larger and slightly smaller than 0.785. And that sort of seems like a strange value. So let's start with maybe 0.8. I mean, that looks pretty close, right? I mean, it's close to 0.785, slightly larger. And there's, again, nothing special about these points that I'm picking except that they better be getting closer to 785 as I go down my table. So maybe now we pick 0.79. That's closer. Maybe then we pick 0.789. Again, closer, but still slightly larger. There's nothing special about these numbers. In fact, they're probably not even the numbers I wrote down on my sheet. And then we can do the same thing for slightly smaller. Now, slightly smaller is actually really nice because I could put 0.7. That's slightly smaller. I'm going to cheat. I'm going to put 0.78. And I'm going to put 0.785, recognizing that, remember, this had some more stuff after it, didn't it? We're the ones who just cut it off. So these numbers would be nice. We could use them. So what are you going to do for me by Wednesday? Fill in the rest of the chart. And what your goal is to see approximately what the slope is approaching. Okay?